All right, hi you guys. Today we are going to be looking a little bit more closely at what happens when we solve inequalities using multiplication and division properties of inequality. But what's going to make this different today is we are going to be looking very closely at what happens when the coefficient is a negative. So the goal for today is for you to understand how to solve inequalities when you're multiplying or dividing both sides by a negative number. Let's take a look at a pretty simple example. Negative 4c is less than 8. We're going to focus on what's going to be different about this. So the first time I go through the problem, I'm going to solve it the way that we probably would all approach this problem. And what you're going to notice pretty quickly is that something is weird. So let's go through our steps. I'm going to take both sides, obviously, to isolate the variable. I'm going to divide by negative 4. I'm going to divide by negative 4, which should leave me with c is less than negative 2, right? We think we're right. We think we're on the right track. But then something weird happens when we go to check it. We'll talk about the graph afterwards. When I go to check this, I know that I should be checking it with numbers less than negative 2. Numbers like negative 3, negative 4, negative 5, on and on and on, right? Numbers that are below negative 2. Well, let's see what happens when I check going back to the original equation. Negative 4 times negative 3 is less than 8, right? I'm back at my original equation, but here's where the problem lies. When I simplify that down, I'm left with 12 is less than 8. Something's wrong because it's not. Well, maybe we just didn't go like low enough. Maybe something like that. So let's see what happens if this time we try to check it with a negative 4, right? So we're going to go a little bit lower. So here's what we've got. Negative 4 times negative 4 is less than 8. Negative times negative, that gives me positive 16 is less than 8. Again, it's not working. Well, maybe I didn't go low enough. This time, let's see what happens if I go way lower, like a negative 10. Negative 4 times negative 10 is less than 8. That's 40 is less than 8. I'm going in the total wrong direction. Why are none of these working? Well, let's see if we can find some number that will check. Let's see this time if when I go through my steps for solving, right? So I'm going to go back to the beginning. We're going to start this all over. Negative 4c is less than 8. I'm going to divide by negative 4. I'm going to divide by negative 4. Let's just see what happens if I plug in numbers this time that are greater than negative 2. Okay? Notice what I did. I flipped the sign because now I just want to check and see like what will happen if I try checking it with like say a negative 1 or a 0 or even like a 5, right? Numbers bigger, greater than negative 2. So let's plug in a negative 1. I've got negative 4 times negative 1 is less than 8. 4 is less than 8. Numbers greater than negative 2 are checking. Let's try it again. Let's see what happens if this pattern continues. Negative 4 times 0, is that less than 8? That's 0 is less than 8. Yeah, I'm even getting numbers now. The larger the number is I plug in, the smaller the product gets. Again, it worked, it worked, it worked. So what does this tell us? I think this tells us that when we divide both sides by a negative, that's what we're going to need to do. We are going to need to flip the sign. All right, we're not going to graph this. Let's go on and try some more examples and see what happens. Let's keep this in mind that something strange may happen. We may need to do some flipping of the sign. All right, let's try one where we're going to be multiplying both sides. So here we've got, let me just enlarge that a little for you guys. K divided by negative 4 is greater than 1. Let's see what happens if I try to solve this the old way. Okay, let's split our page in half, and we'll do it the old way, and then we'll try it the new way. So the old way would have me taking both sides of the equation and multiplying by -4, which should leave me with, the old way, k is greater than -4. The easiest number greater than -4 for me to check with, right? Numbers greater than -4. I'm going to try checking it with like a 0, a 4, right? Numbers that are going to be easy and compatible for me to check. So let's see what happens when we check it with a 0. 0 over -4 is greater than 1. 0 is greater than -1. It's not checking. Let's see if I check it this time with a 4. 4 over -4. That should work, right? Except that it doesn't. -1 isn't greater than 1. So again, none of these are checking, right? None of these are checking, and there's a reason why. Let's see if we check numbers that are greater than -4. Let's see if that new way works for this. So let's go back to the beginning. K over -4 is greater than 1, right? That's our original. Let's see what happens when I multiply both sides, and I multiply both sides, and let's see what happens this time. Look what I'm going to do. I'm going to change that greater than into a less than. K is less than -4. Well, let's think of some numbers that are less than -4, but also compatible with 4 so I can divide it easily. I'm going to check it with like a -8 or a -12. Let's see what happens when I check it with a -8. -8 divided by -4 is greater than 1, right? I'm back at the original equation. 2 is greater than 1. Look at that. It checks. Let's try it with a -12. -12 divided by -4 is greater than 1. Look at that. 3 is greater than 1. These numbers are checking, which must mean that k isn't less or greater than -4. Instead, k is less than -4. So once again, on this problem, we flipped the sign. Let's try another example, and this time, let's just flip the sign to start with. And then we'll talk about why we flip and when we flip. So here's the problem. -2b is greater than or equal to -10. I'm going to divide by -2, divide by -2. I am going to flip the sign first in this problem. Can you think of what you saw in all three examples so you know when we flip? How do we decide when we're going to do that flip? This is a problem where I know I'm going to flip. Do you know why? Do you see that I'm dividing both sides by a negative? That is when we're going to flip. When we divide or multiply both sides by a negative, we know that that's when we're going to flip the sign. And so, I see a negative, I see a negative. I am going to solve this as b is less than or equal to 5. And this time, instead of doing it wrong a whole bunch of times, I'm going to check it right. Let's think of a number that is less than 5. I'm going to choose 4, a number less than 5. Is it true that -2 times 4 is greater than or equal to -10? Well, that simplifies to -8. -8 is closer to 0, so yes, indeed, -8 works. Notice how I did not need to go and do the problem a whole bunch of times. Instead, I was able to look at this problem and go, okay, I divided by a negative. I divided by a negative. When I see a negative, I know I'm going to flip. Okay, so we flip when we divide or multiply both sides by a negative. Okay, and if we were going to make the graph for this problem, that would be pretty simple. We are graphing the solution. Our solution is b is less than or equal to 5. So I'm going to plot my 0 and my 5 and put a closed circle and look at which way I'm shading to the left because b is less than. Let's try another. X over negative 2 is greater than or equal to negative 2. I see that I'm going to need to multiply both sides by a negative 2 and a negative 2. I'm thinking about what we said in the last problem. If I do the same thing, divide or multiply both sides by a negative, I'm going to do that negative flip, right? If what I'm doing on both sides involves a negative, like it does here, then I know, okay, negatives on both sides means I'm going to flip that sign. These cancel out. We're left with x is less than or equal to 4. I'm not going to do it wrong a bunch of times. I'm going to check it the right way. An easy number less than 4, I'm going to check it with a 2. Let's see what happens if I check it with 2 divided by negative 2. Is that really something that's greater than or equal to negative 2? Negative 1 is greater than or equal to negative 2. It checks. Okay, so now let's go and graph our solution. Remember that what we're graphing is, right? Remember, let me say this again. Remember we check it in the original. But remember that we graph the solution. So I am graphing this x is less than or equal to 4. There's my 0. There's my 4. It's a closed circle. And my shading is to the left. Okay, so here's the rule. The rule is this. Make sure you have this in your notes. It is important. When you multiply or divide both sides, not just one side, by a negative, we flip the symbol. Does that make sense? All right, why don't you guys pause the video, do these next two problems, and then you can check it with my work. I'm going to divide both sides by negative 5, which tells me that I'm going to flip. I've got D is greater than or equal to negative 3. I'm going to check it with something greater than negative 3. I'll pick 0. Negative 5 times 0 is less than or equal to 15. True, it is. Okay, and I'm not going to graph these. I'll just solve them. And for the next one, I'm going to get rid of that negative 3/5 by multiplying both sides by the reciprocal negative 5/3 and negative 5/3. I know that these cancel, and here's what I've got. Negative 10. I multiplied both sides by a negative, so I'm going to flip that, is greater than or equal to W. Okay, so I know some of you like to rewrite that as with the variable on the left, so that's the same thing as saying W is less than or equal to negative 10. I'm going to check it with a negative 15, right? That's a number that's less than negative 10. Let's see what happens when we check it in the original. 6 is less than or equal to negative 3/5 times negative 15. That's 6 is less than or equal to 9. And look at that. It checks. Okay? So the rule is when you multiply or divide both sides by a negative, we flip the symbol. I like to think of that as negative flip. All right. Thanks, guys. Bye-bye.